We start off with a graph here. We do our analysis, our Oizurga analysis. The origin, if we're careful to see 7, 6, 5, 4, 3, 2, 1, it's actually 0 is over here. So it's not quite at the origin. And moving downward, 4, 3, 2, 1, 0, it is 0. But when we look at the overall Cartesian plane, it's actually situated about right here, not exactly up against the origin. Y-axis is force in normal units, x-axis time in normal units. So therefore, any questions about force and time would be read off the graph. The slope, delta F over delta T, is the rate of change in force. And the area is F delta T, which we recognize as the definition of impulse. And the impulse imparted happens to bring about a change in momentum, m delta V, and those four things are equal to each other. So the area of this graph is going to be the change in momentum or the impulse. And if we wanted to find that area of this event that occurs over 2 seconds, we see the F max is 4. So the average force is 2. So the area that we're looking for is really the area of this rectangle. And of course, you could see that the area of this triangle will equal the area of that triangle, and the area of that triangle will equal that one. So we are looking at a height of 2 and a time of 2. So we are looking at a J of 4, a delta P equal to 4. So we do all that right even before we read the question. And what we're told is a cart of 1 kilogram mass traveling along a horizontal frictionless surface, so it has some V0 and it's 1 kilogram. A force is applied to cart A. We see the graph, which we've already analyzed. The initial and final direction of the cart and the direction of the net force is unknown. So what that means is that the velocity could be either of these two, and the force could be in this direction, or the force could be in this direction. So we could have a situation where it's moving in this direction and there's a force in the same direction, in which case the velocity would increase and the momentum would increase a certain amount. And that increase would be 4. It could be that the cart is moving in this direction and it experiences a force in this direction. So the change in momentum would be positive 4. Or it could be headed in this direction and the force is in this direction, in which case it's going to speed up and the change of momentum would be 4. And the other possibility is it's moving in this direction and the force is in that direction, so the change is in this direction, the amount of 4. So we are told in these graphs down below that on the grid, 1 unit represents the change in velocity of 1 meter per second. And since it's 1 kilogram, we have 1 kilogram in each block is 1 meter per second. Well, the change in momentum is 1. And we know the change in momentum from our area calculation is 4. So we're looking for a change in 4. And that change, remember, can be plus 4 or it can be minus 4. So if we look at this one, this has a value of minus 1. And this has a value of plus 3. So if you look at the change in momentum, which is the final minus the initial, if we have 3 minus a minus 1, that's a change of 4. So it looks like this could be a correct answer. Now keep in mind, we're looking for 2 correct answers. We look at this one, this is minus 1 and this is 1 afterward. So the change in momentum is actually 2 delta P, P minus P0. 1 minus a minus 1 is 2. So B is out. We look at this third one, it's 0 and plus 3. Well, we can see that change is 3, and that's out. And we look at this last one, it's 1, and then it's 5. So the change is, again, 4. Delta P, final 5 minus the initial 1 is 4. So its choices A and D.